Welcome to this highly interesting pneumatic bicycle building project. The fatigue from traditional pedaling motivated this bold mechanical idea. The guy brings a blue compressed air tank and the bicycle into the workshop. Here, the mechanic is inspecting an industrial aluminum pneumatic cylinder. The basic principle is to convert pneumatic pressure into linear motion to create thrust. First step, flip the bicycle upside down. Use a wrench to loosen the rear wheel nuts. The rear wheel is quickly removed to prepare for the drivetrain upgrade process. A bicycle freewheel assembly and a retaining jar placed on a thick steel workbench. He is aligning the hub with the drive sprocket to synchronize the mechanical power. Using a high-speed angle grinder, he trims the inner diameter of the steel sprocket, a grinding operation that requires high precision, so the sprocket fits perfectly with the hub mount. Secure the sprocket to the mount using specialized anti-vibration locating bolts. The bolts are temporarily hand-tightened before using a battery-powered impact wrench. The powerful impact wrench tightly locks the sprocket and freewheel assembly, ensuring it can withstand torque loads. Checking the smoothness, the freewheel bearing system spins very smoothly, without any axis wobble. Reinstall the rear wheel onto the bike frame. Align the chain and tighten the axle with a wrench, ensuring the wheel is balanced, and the newly installed sprocket does not rub against the frame. Tighten the axle retaining nuts, ensuring the rigidity of the new chain drive system. Next, remove the original pedal crank assembly, using an impact driver and a hammer to loosen it. Mock up the pneumatic cylinder on the frame. To calculate the linear stroke of the piston, use a blue marker to mark the cutting position on the extruded aluminum crank arm. Clamp the crank arm tightly in a vise. Continue using the grinder to cut off the excess part. The cut generates many sparks. The aluminum billet is completely removed from the bottom bracket assembly. Reattach the short remaining stub to the bike's bottom bracket, then add a small sprocket. Using an arc welding machine, weld the sprocket to the bottom bracket stub to create a power transmission structure. Grind the weld flat to remove slag, to avoid chain jamming during device operation. Prepare a small metal bearing and a steel sleeve to make a ball joint. Hammer the bearing tightly into the steel tube to form a flexible pillow block assembly. Weld this bearing assembly to a standard threaded rod to create a mounting bracket connected to the cylinder. Clean the weld with a chipping hammer and a steel file to shape the metal surface. Tighten the custom joint to the threaded end of the piston rod, belonging to the pneumatic cylinder. This bearing will help the piston move flexibly, absorbing twisting forces from the bottom bracket. Mock up the cylinder on the rear swing arm of the bike. Measure the tilt angle and load bearing distance. The mechanic places a steel locating rod to prepare to weld the bracket fixing the rear of the cylinder. Arc weld the U-shaped steel mounting bracket onto the bicycle frame. To install the rear of the cylinder into the bracket, to determine the perfect fixing position, insert a bolt through the ball joint. To connect the piston rod to the sprocket at the bottom bracket, use a wrench to tighten the nuts, ensuring the linear force is fully transmitted to the axle. Align the cylinder parallel to the frame, ensuring the piston stroke is not skewed. Remove the threaded nut at the rear of the cylinder. Position a flat piece of steel as a bracket. This steel bracket will bear the entire reaction force when the cylinder pushes at full stroke. Continue to permanently weld this steel piece to the lower frame of the bicycle into a solid block. Tighten the rear nut to lock the pneumatic cylinder assembly onto the bike frame. The yellow nut prevents rotation, keeping the cylinder always aligned with the pull axis. Take out a mechanical pneumatic lever valve, an important component to reverse the airflow. Weld a small round eyelet to the tip of the valve lever to create a connection hook point. Clean the welding slag. Check the flexibility of the valve lever. After being heated, weld the nut to a small round steel piece to make a mechanical drive pull rod. The two mechanical valves are ready. Prepare a small wooden base to create a mounting point. Use a battery-powered drill to drive screws through the valve block. Firmly secure the valve assembly to the wood. This step insulates it and creates a bracket that can be easily adjusted on the bike. Slide the compression spring and washer onto the steel pull rod to create a stroke damping mechanism. This spring mechanism prevents the valve from breaking when the piston moves with too much force. Thread the pull rod through the round eyelet of the mechanical valve lever to synchronize the sliding motion. Secure it with a washer and a small nut at the other end to lock the spring assembly in place. Adjust the nut clearance to precisely calibrate the switching amplitude for the pneumatic switch. This automatic slide valve system is the heart that controls the engine cycle. Mount the reversing valve assembly onto the frame, parallel to the cylinder's operating axis. Connect the valve pull rod directly to the pin of the piston rod head, currently attached to the crankset. Tack weld to position the valve bracket onto the rear fork of the bike to secure it. Tighten the auxiliary pull rod to firmly establish the kinematic between the piston and the valve assembly. Continue arc welding so the valve block assembly is securely attached to the load-bearing frame. Reinforce the welds on the crankset power transmission assembly to ensure it withstands high pressure. Mount the second valve assembly on the opposite side to create a dual reversing system. Fully weld the base of the second valve to complete the mechanical brain of the pneumatic bicycle. Install the rear cargo rack. This will be a solid base for the compressed air tank. Insert locating bolts through the rack mounts and the pre-drilled holes on the rear wheel axle frame. Use a ring spanner to securely tighten the nuts, pressing the rack frame firmly against the bike fork. Double-check the entire screw system on the rear wheel axle to ensure absolute safety. All mechanical details are locked tight, ready for the pneumatic hose routing step. Install the steel chain connecting the main sprocket to transmit power straight down to the rear sprocket. Check the chain tension to ensure the drive system rotates smoothly without jamming or catching. Weld and fix the left pedal crank to the bottom bracket to balance the torsional force. Place the large blue high-pressure compressed air tank onto the rear rack. Arc weld steel support brackets to lock the air tank firmly onto the rack frame. Start plugging the transparent PU air hoses into the mechanical valve assemblies. The switching valves will open and close the air ports rhythmically, directing pressure to drive the piston's linear motion. Use a T-connector to split the compressed air from the main tank to the two valve assemblies. Plug the hoses from the valve output ports into both ends of the cylinder's pressure chamber. When valve 1 opens, air pushes the piston forward. When valve 2 opens, air pushes the piston backward. Connect the coiled pneumatic hose from the tank to the splitter assembly. Overall, the pneumatic engine drive system is now fully assembled on the bicycle frame. Connect the quick splitter from the electric air compressor to the air tank's intake port. A pressure gauge indicates the amount of compressed air being filled into the tank. Remove the compressor intake hose while keeping the red lock valve open to supply airflow to the system. Immediately, the pressure releases, driving the cylinder back and forth continuously to spin the chain. The reversing slide valve mechanism works absolutely perfectly, with a rapid discharge and intake rhythm. The creator gets on the bike for a test ride. The bike surges forward powerfully without needing pedaling force. A close-up shows the pneumatic cylinder system, pulling the sprocket chain very smoothly, transmitting power down to the rear wheel. The traveling speed on the asphalt road is very impressive, thanks to the continuously discharged compressed air. The mechanic cruises swiftly down the street. The uniquely crafted bike operates flawlessly and extremely stably. The compressed air in the blue tank still provides enough kinetic energy for an extended journey on the streets.